Postulates of quantum mechanics. What is mean postulates? It is true, but we can't prove it, and we have no evidence to show that it is wrong. That is the postulates. Postulate 1. In this quantum mechanics, motion of a particle is described by wave function. Wave function is a mathematical function. It gives about location and motion. It gives about position and momentum of the particles, and it gives the detail about possibility of the particles. In this graph, show you wave function versus position. You show the A, B, C point of the function. A position, the particle is in A position, wave function, you show the height. And it has high possibility. It means we can find the particle at that position. Particle is in B position, wave function is 0. And 0 possibility, we can't find the particle at that position. And C position, particle is in C position, wave function is high, and the possibility is high, and we can find particle easily. In here, not consider the wave function is positive or negative. In this graph, you show the rapidly change the wave function of in this area. It's mean that has high kinetic energy, but in this area, no rapidly change the wave function. That's mean low kinetic energy has in this area. What are the special properties of this wave function? Psi must be continuous. Wave function must be single value. Wave function must be finite within the considered region. Wave function must be normalized or normalizable. Okay, let's we talk about details in that points. Psi must be continuous. In this graph, you shows continuous graph, but in this graph, not continuous. No, this is wrong. Psi must be like this. Psi must be single valued. You show this graph, psi at that point in that position, there are two values for the wave function. So it's incorrect. Psi must be single valued each points. Psi must be finite within the considered region. You show this graph, it has infinite value for the wave function. It is not correct. Wave function in this region, we consider region, so wave function must be finite within the considered region. Psi must be normalized or normalizable. Understand about the probability and probability density function. This shows the probability density function. Psi is a wave function and psi star is a complex conjugate wave function. For example, you know the mathematics, you know very well about that. So example I give you, this is the wave function, this is the conjugated wave function value. Sign mark is change, and this graph show you the function. And for the range AB probability density, this is the equation. If probability density for AB region is 1, it is normalized. In this, according to this equation, probability density is equal to 1, it is normalized. And probability density not equal to 1 and it has another value, it is normalizable. We talk more details in next video.